Hello, we're going to do a couple more examples of integration using partial fraction decomposition. This is a second video, so if you go to the first video, there is an explanation of partial fractions. This video is just going to focus on doing a couple more examples. So for our first example, I'm going to show the partial fraction decomposition over on the side. First thing we want to do is factor the denominator. So for our first example, I'm going to show our partial fraction decomposition over on the side. And first thing we want to do is factor that denominator. This denominator factors to x minus 3 times 2x minus 1. And we're going to say this equals some constant over x minus 3 plus another constant over 2x minus 1. The rest of this is we want to isolate a and b. So to do that, I'm going to start by getting rid of our denominators. We're going to do that by multiplying both sides of the equation by x minus 3 times 2x minus 1. That gives us x minus 13 on the left. On the right, that gives us a times 2x minus 1 plus b times x minus 3. From here, I'm going to strategically choose values of x that will give me a and b. So first, I'm going to let x equal 3. That's going to help me isolate a. On the left side of the equal sign, 3 minus 13 is negative 10. On the right side, I'm going to have a times 6 minus 1, which is 5, and my b term cancels. So I get a equals negative 2. To get b by itself, I'm going to let x equal 1/2. On the left side, I have 1/2 minus 13, so let's show some work over on the side. 13 is 26 over 2, so this is negative 25 over 2. On the right side, my a term cancels because 2 times 1/2 is 1, and 1 minus 1 is 0. And then I have b times 1/2 minus 3. So if we need to show work, we can do that. We get negative 5/2. And to isolate b, I'm going to multiply both sides of the equation by negative 2/5. Notice that your 2's cancel, your negatives cancel. 25 divided by 5 is 5. On the right side, we get b. So b is 5. So we have a is negative 2 and b is 5. So I can go back to my problem and I can rewrite my integral plus 5 over 2x minus 1 dx. So let's finish our problem. I'm going to split this into two separate integrals, I should say. And I'm going to bring my constants out front. For both of these, we are going to be using u substitution. I'm going to let u equal x minus 3, du is dx. For the second one, u is 2x minus 1, du is 2dx. That means I need a 2 in front of the dx, which means I need to divide by 2 out front in order to be multiplying by 1. We're also going to be using the property that the integral of 1 over u du equals natural log of u plus c. So we get negative 2 natural log of x minus 3 plus 5 over 2 natural log of 2x minus 1 plus c. And that is our answer. Let's move on to the second one. Same thing, I'm going to do partial fractions. I'm going to show my work over on the left. Start by factoring the denominator. So we're going to say this equals sum a over x minus 2 plus sum b over x plus 2. get rid of our denominators. I'm going to multiply both sides of the equation by x minus 2 times x plus 2. We get 12 equals a times x plus 2 plus b times x minus 2. To isolate the variables, I'm going to start by letting x equal, or I should say isolate the constants. I'm going to start by letting x equal 2. We get 12 equals 4a, the b term cancels, and a equals 3. I'm also going to let x equal negative 2. That's going to cancel out our a term. We get 12 equals negative 4b, so that means b is negative 3. So a is 3, b is negative 3. So I can go back to my integral. I can say this equals 3 over x minus 2 minus 3 over x plus 2 dx. I'm going to split this into two separate integrals, and I'm going to bring my constants out front. Okay, we are using u sub for both of these, but notice in each case, du equals dx. So unlike the first problem, I don't have anything else I need to put in here to make my u sub work. So I'm going to get 3 times the natural log of x minus 2 minus 3 times the natural log of x plus 2 plus c. Oops, not plus 3. Let's make it plus c. Okay, so we have one more example. I'm going to do my partial fractions over on this side. I'm going to start by factoring my denominator. I have a GCF of x squared. And we said in the first video, when you have a factor that's repeating, so I have my x that's repeating, you're going to start by saying this equals sum a over x, and then you're going to increase your exponent until you get to the exponent that's in your problem. So I have x squared, so I'm going to say a over x to the 1 plus b over x squared. And if this were an x cubed, we would add a c over x cubed. We would keep increasing that exponent until we got to what we have. So this would be plus c over x plus 4. X plus 4 only occurs once, so that is how we are used to. Okay, so let's get rid of our denominators. I'm going to multiply by x squared times x plus 4 on both sides. And we get 3x plus 8 equals ax times x plus 4 plus b times x plus 4 plus cx squared. That's after we've canceled out our denominators. I'm going to choose a couple values of x, see what we can isolate. I'm going to start by letting x equals 0. That's going to help us isolate b. That's going to give us 8 equals, the a term cancels, I get b times 4, and the c term cancels. So that means that b equals 2. I'm also going to let x equal negative 4. That's going to help us isolate c. On the left side, negative 4 times 3 is negative 12. So I have negative 12 plus 8. My a term cancels, my b term cancels. I get c times negative 4 squared, which is 16. Simplify this. Negative 12 plus 8 is negative 4. And that means c is negative 1/4 after I simplify that fraction. Now from here, there isn't really a number we can plug in for x to help us isolate a. So we're going to need another strategy. What we did before is we said that I can equate some of my coefficients with each other on each side of the equal sign. So notice that, how do we want to do this? On the left side, I have 0x squared, because I don't have an x squared term, plus 3x plus 8. And if we're just doing x squared terms, you can choose any term that you want that involves a. So if we're just looking at the x squared term, I'm going to have an ax squared. The b's, there's no x squareds in there, and then I'm going to have cx squared. So I'm going to say that 0x squared is going to equal my ax squared plus cx squared. So if I factor out my x squared, this is going to mean a plus c is going to have to equal 0. I'm equating those coefficients. We know that c is negative 1/4. Add 1/4 to both sides, we get a equals 1/4. So I just chose to equate the x squared terms. We also could have chosen to equate the x terms. Notice if I distribute ax, we get 4ax, and then I would also have my bx. So we would look at both of those and equate those to the 3 in front of the x. So multiple ways to do it, but we did get our 3 constants. So I'm going to rewrite my problem. We said 1/4 over x plus 2 over x squared minus 1/4 over x plus 4 dx. Okay, next step, I'm going to write these as separate integrals. I'm going to put my constants out front. And thinking ahead, this is an x squared in the denominator, so I'm not going to be using natural log for this one, so I'm going to put x to the negative 2 instead. Okay, so for the first and the third integral, we are using u sub. Notice that in both cases, du equals dx. So we get 1/4 natural log of x plus 2, increase your exponent, so negative 1, multiply by negative 1 out front. So I'm going to change this positive to a negative. And then we have minus 1/4 natural log of x plus 4 plus c. I'm going to rewrite it one more time because we don't want a negative exponent in our answer. And that is our answer. So these were a few more integration by partial fractions examples.